Hello guys, welcome to my channel. Imagine yourself sailing across the ocean with monster waves and extreme weather crashing against your vessel, threatening to swallow everything in their path. Hundreds or thousands of sailors on these ships are at constant risk, not to mention the 60 to 90 parked aircraft on Navy carriers that could cost over $10 billion. Navy ships navigate through raging storms, battling unpredictable hurricanes and deadly typhoons that can appear unannounced on the horizon. How do they handle big storms with monster waves? Life in the vast ocean is always at risk, and the sea conditions are very different from the steady and calm environment of safe harbor. Make it a lot more dangerous for U.S. Navy sailors who are often out on long missions lasting months at a time, and as we know, winds are the driving force behind weather at sea, creating ocean currents that dictate how violent the weather can get. Ships can encounter high-speed winds of over 60 knots, or almost 70 miles per hour, and waves of up to 300 feet during storms and hurricanes. Waves exert considerable force on a U.S. Navy ship's structure, making it difficult to maintain a steady course and increasing the risk of capsizing. An unstable ship would cause the heavy equipment and machinery on board to shift, injuring the crew and damaging the ship. On any given day, around 50,000 U.S. Navy sailors are deployed globally aboard any one of approximately 100 ships, demonstrating how important it is to keep everyone safe. Even though the U.S. Navy has implemented some of the best measures to prevent accidents, sometimes Mother Nature can be unbeatable. On October 1, 2015, the SS El Faro was lost at sea with her entire crew of 33 after steaming into the eyewall of a hurricane. Has not been found either, but luckily, since tragic incidents like the loss of the El Faro, the Navy has dramatically improved ship safety through more stringent protocols. Advanced engineering and cutting-edge design, but will it be enough the next time a perfect storm arises in engineering and design before we get into the details of all the amazing engineering tech on your fingertip? Now imagine trying that on a roller coaster ride. That's just a peek into the incredible play of physics and naval engineering that keeps the ships afloat through rough seas. Now let's look at the critical elements that keep the U.S. Navy ships straight afloat, preventing them from capsizing. As per the basic rule of science, objects float when they have a lower average density than water and less upward force exerted by the water. Another point worth noting is that the lower the center of gravity, the less likely an object will tip over, so all U.S. Navy ships maintain a low center of gravity by keeping heavy machinery, fuel, and equipment on the lower levels. Engineers on board carefully calculate the placement of all equipment and the installation of new machinery. The ship's hull has a large U-shape that provides stability and prevents it from rolling, tilting, or dragging in rough seas, but larger U.S. Navy ships, like aircraft carriers, have V-shaped hulls that can cut through large waves in contrast to smaller ships, which are highly susceptible to wave height. Navy aircraft carriers use ballast systems to maintain level, which work like Lady Justice's scale. Advanced technologies. In addition to these basic designs and systems, the U.S. Navy has incorporated some advanced technologies into its ships to ensure their safety. The Navy's mission of operating for long periods at sea while conducting precision strikes and bombing runs makes fin stabilizers an operational necessity. They counteract constant rolling and pitching motions and allow ships to maintain stability in rough seas and maximize weapon system effectiveness. Fin stabilizers turn potentially unstable vessels into warships capable of precise coordinated lethality in challenging ocean conditions. They are a crucial technology that helps the Navy maintain freedom of the seas around the globe. Gyroscopic stabilizers are another example. Tires of the bicycle. As long as the tires are spinning, the bicycle will stay upright. A gyroscopic stabilizer is a vacuum-enclosed sphere with a flywheel that spins at a high speed of around 10,700 rpm. The flywheel creates angular momentum, which produces torque, which pushes and pulls the ship to keep it level. It can be operated by a computer. The tilt of the gyro allows it to provide full torque in a wide range of sea conditions. Self-righting vessels are increasingly being developed to mitigate damage from potential capsizing events. Boats that can automatically operate themselves after capsizing could be invaluable for the U.S. Navy, allowing smaller crafts like ribs or rigid-hulled inflatable boats to quickly self-right and resume operations after rolling over. Weighted keels, bottom ballast tanks, or angled hulls that provide a righting moment once the boat rolls past a certain angle. Upon sensing a capsize, onboard computers can immediately activate pumps to shift water between tanks, aiding the natural righting process.
maintenance and inspection. With all these sophisticated systems in place, the U.S.
As expected, warships must remain operational 24/7 to perform all their functions at the highest level of perfection, so proper ship maintenance is essential to identify and address issues before they become safety hazards. This requires a highly skilled and dedicated team of sailors and engineers to perform cleaning, painting, repairing, and upgrading.
Staying one step ahead of trouble is also known as a planned maintenance system.
Lubricating machinery, fluid level correction, functional tests, performing visual inspections, and vibration measurements are some of the fundamentals of preventative maintenance.
It makes sure every nut and bolt is in its place.
Corrective maintenance comes into play when a ship has failed, malfunctioned, or been damaged.
Ships are expensive to operate, but their costs can skyrocket if an equipment breakdown occurs at sea, necessitating emergency repair.
So preventative maintenance helps keep operating costs in check while reducing the risk of equipment breakdowns that could capsize the ship. Dry docking and overhaul maintenance are also done to understand them.
Hull propellers and rudders work not possible underwater. Meanwhile, overhaul maintenance involves disassembling, inspecting, repairing, and reassembling various ship systems. Every system on U.S. Navy ships must be in top condition to withstand unexpected storms. Neglect means risks at sea, and there's no room for surprises.
Weather forecasting. Speaking of surprises, the U.S. Navy works tirelessly to avoid harsh weather and avoid routes. Let's look at the U.S. Navy's advanced and sophisticated weather forecasting systems to help crews plan routes and navigate bad weather.
The Navy helps ships navigate rough seas safely.
When tracking ocean weather conditions, special meteorological and weather tracking satellites orbiting the Earth's poles collect data on clouds, air and water temperature, currents, dust storms, and ice coverage for the U.S.
Weather buoys are the next most common type of weather forecast instrument used by the U.S. Navy.
There are more than 1,000 weather buoys around the world, which helps the Navy plan their routes out in the ocean. These buoys can measure winds, waves, barometric pressure, air, and sea temperatures, which can be used to predict hurricane formation or dissipation.
Strong environmental models like Joint Typhoon Warning Center and Wave Watch 3.
In addition to these external sources, U.S. Navy ships are equipped with anemometers to measure wind speed, barometers to measure atmospheric pressure, and weather radars to detect storms and precipitation based on these predicted weather conditions.